Hey everybody! Today I want to teach you what square roots and cube roots are. Please make this title on the next free page in that math notebook. When you have done that, close it up, concentrate, and I'll tell you when it's time to write. Before we get started on square roots and cube roots, I want to remind you, sometimes math has what I like to call like invisible numbers, numbers that are there but you don't have to write. Often those are numbers that are ones. For instance, when we write 3x like this in an equation or expression, that means there's 3 of the x. If we did the drawing strategy, and we would write 3 of those, or it means 3 times x. And this is the same as 1x. We just don't have to write the 1. If you were to see an equation like, 4x plus x plus 5, you would know that's 4x and that's 1 more x. You could combine those to make 5 because that's 4 and that's 1 more. You don't have to write the 1. Fractions, we have always an invisible denominator. That's the number 2/3. If we want to make 4 into a fraction, it has a denominator of 1. We just don't have to write it. I call that an invisible number that's kind of there when you need it, but you don't have to write it. Exponents, same thing. 6 to the 4th power, that's 6 times 6 times 6 times 6. If there's no exponent, it's kind of the same as 6 to the 1st power, which is just 6. So all those are invisible numbers. Invisible numbers are usually ones, and they're just a thing I want to draw your attention to because they're going to kind of come in today a little bit. The other thing I want to draw your attention to, in math, operations have an inverse, right? Addition and subtraction are inverse operations. 3 plus 5 is 8. Inversely, 8 minus 5 is 3. They have kind of the same opposite relationship. Adding 5 and subtracting 5 are sort of inverse operations. Multiplication and division are inverses. 6 times 4 is 24. Inversely, 24 divided by 4 is back to 6. The operations kind of undo each other. And gets me to thinking, what's the inverse of an exponent? 5 to the 3rd power is 125. What's the inverse operation of that? How do you kind of go backwards? If I want to go from 3 to 8, I add 5. If I want to go 8 back to 3, I subtract 5. 6 to 24 times 4. 24 back to 6, divide by 4. Inverse operations. What is the inverse of that? Well, they're called square roots and cube roots, are the inverse operation of squaring and cubing. So what that kind of means, square roots are the inverse operation of squaring. Squaring is another way of saying second power. So for instance, if I write 5 to the 2nd power, I can say that as 5 to the 2nd power. I can also pronounce that 5 squared. So 5 squared is 25. It's 5 times 5. The inverse of that is what we call a square root, which we write under a symbol like this, if you've ever seen that before in your calculator or elsewhere. So 5 squared is 25. The inverse operation of that is that the square root of 25 is 5. They're inverse operations. 5 squared is 25. The square root of 25 is 5. It's the number that, when you square it, gives you that. Similarly, 10 squared is 100. Inversely, the square root of 100 is 10. It's just the inverse operation of squaring. Cube roots are the inverse operation of cubing. Cubing, remember, is another way of saying 3rd power. So if I wrote, say, 2 to the 3rd power, I could also pronounce that 2 cubed. And 2 cubed is 8. Inversely, the cube root, same symbol, but you do a 3 for an exponent of 3. The cube root of 8 is 2. 2 to the 3rd power of 8. Cubed root of 8 is 2. Let's do one that's easy to cube, kind of. Cubes get big really quick. 4 cubed is 64. And inversely, the cube root of 64 is 4. That's what cube roots and square roots are. Now you'll notice cube roots, I had to write a 3 here. Cube. Square roots, I didn't have to write a 2 here. You can, it is not wrong to write a little 2 in your square root, but much like invisible numbers that I talked about before, lots of times there's invisible ones. It is okay to keep the 2 in a square root invisible. So when you see it with no number, it's implied that it's a second root, a square root. To do a cube root, you'll always see the 3. And, of course, there's fourth roots and fifth roots and stuff too. We're not going to really get into those, but they exist. So the way those work, square roots and cube roots, they either come out real clean or real messy, right? So the square root of 16, what I'm thinking to myself is what number squared gives me 16? What number times itself is 16? So that is 4. Cube root, because 4 times 4 is 16. 4 squared is 16. The cube root of 1,000, I'm thinking to myself, what number to the third power is 1,000? In this case, it is 10. 10 squared is 100 times 10 again is 1,000. 10 to the third power is 1,000. 10 times 10 times 10, right? Square root of 2 and 2500ths, I don't know that one. I'm going to use a calculator for that, but I'm going to show you it's still going to come out pretty clean. Let me get my calculator here. Go. So probably your calculator has a square root button. You'll see mine even has the invisible 2. So the square root of 2 and 2500ths, click the square root button, is 1.5. What that tells me is that 1.5 times itself is 2 and 2500ths. This one I can do, again, real clean, square root of 1/4. What times itself is 1/4? It is 1/2 is that square root. 1/2 times 1/2 is 1/4. So often square roots will come out real clean, right? If they don't come out real clean, they come out real messy. It's like square root of 5. I'm thinking to myself, what number squared equals 5? I don't know that off the top of my head. 2 squared is 4. 3 squared is 9. I don't know what squared is 5. And let me just show you, you really wouldn't come up with it. The square root of 5 is that. That number times itself makes 5. So we usually have to approximate those and say, okay, it's about 2.23, something like that. I can go out farther if I want. The cube root of 15, I don't have a calculator that will even do cube roots. So I'm going to skip that one. It would not come out clean either. Square root of 7.25, 7/2500ths. Square root, look at that. I mean, no way you're ever going to come up with that. 2, we'll call it 2.69. And square root of 2/5. 2/5 is this as a decimal. Square root is that, 0.6324. Approximately 0.623. So you'll notice what I really want you to know, if it didn't come out real neat, it came out real messy, like a big, long decimal. All right, open that notebook up and let's take a few notes here. We're going to start with the vocabulary words square root and cube root. You can try to keep up with me or you can just let me go and then pause at the end. So what is it? It is the inverse operation of squaring. That is what it is. So again, my example, 5 squared is 25. So the inverse of that, the square root of 25 is 5. That's what a square root is. It is sneaky because we tend to confuse it with half. We tend to think divide by 2. For instance, if I show you like the square root of 10, it's easy to think, oh, that's 5. But it's not. 5 times 5 is not 10. 5 times 2 is 10. Just like it's easy to mistakenly say 5 squared is 10, which it's not. That's sneaky because of that. And we also just don't know very many numbers that come out nicely as a square root. Is not 5. I want to say that. We tend to think that. So yeah, so some quick examples. The square root of 25 is 5. I think I showed you on the last one. The square root of 2 and 2500ths is 1.5. The square root of 121 is 11, and so on like that. Non-examples, that's just things like I said, like this one above. We tend to mistakenly, if we don't know it, like, oh, that's probably 5. It is not. Like some numbers just seem like halving makes sense when you try to think of their square root or something. Or, the square root of 3 is 1.5. It's not. It's just not the same as multiplying by 2. Okay? Cube roots. Oh, go ahead and pause back here if you need to write those down. Cube roots, same thing. They're the inverse operation of cubing. They look like this. There's a 3 with the root symbol. So some examples, again, numbers get big real quick when you cube them. So for instance, the cube root of 64 is 4. 4 times 4 is 16 times 4 is 64. The cube root of 1,000, I think we did, is 10. Again, it is not dividing by 3. That's the main thing to remember. So when you see something like, say, the cube root of 90, it is not 30. It's not the same as dividing by 3. Sometimes we have a tendency to think it is. This would just be a big, long decimal that we wouldn't know. So again, pause here if you need to write down cube roots. They're a new thing today. So the other thing to know today for your notes is that square roots either come out real clean. I should say square and cube. They either come out real clean or real messy. One or the other. There seems to be no in between. Square root of 196 is 14. That means 14 times 14 is 196. You may not know that one in there. This one I think is 6. The cube root of 16 I think is 6. My simple calculator here won't do that. But 6 times 6 times 6 is 216. The square root of 11 and 56/100ths doesn't seem like an obvious one, but I said real clean and real messy, it's going to be. It's 3.4. 3.4 times 3.4 is that. Cube root of 1/9 is 1/3, because 1/3 times 1/3 is 1/9. So I would call all these real clean. They come out kind of nicely. If they don't come out real clean, they come out not just kind of messy, they come out real messy. Square root of 20, temptations to say 10, but it's not. Remember, it's not dividing by 2. The square root of 20 is going to be real messy. 20 square root, boom. Never ending, super long decimal. I'm going to cut it off at maybe 3 decimals, 4.472. I might even put ... to kind of imply like, oh yeah, it's bad. It keeps going. Cube root of 100. I don't have a calculator that'll do that when I put that example in, so I'm just going to skip it. Square root of 16.5. Yuck. 4.062 and so on. I also don't have a calculator to do the square root of 3/8. I do have one elsewhere, but this one won't do. Oh, I bet I know. I think that's I think as a decimal, that's 0.425. Yeah, it is. Yeah, it is. So the square root of that, again, never ending decimal, real messy. 651, 652, something like that. And so on. So that's your first start today on square roots and cube roots. They are the opposite of squaring and cubing, and they either come out real clean or real messy. Hope that made a lot of sense to you today. I hope that was a good start of an introduction, and I hope you feel good about it. If not, give this another go. I know this is a new and brand new thing for you, so give it a second look if you need to, and when you feel good about it, I'll see you tomorrow.